So in Taylor's University, we are very particular of integrity. So I would very much advise all of y'all not to share the attendance code with your friends who are absent. If you do, and if I do find out, it falls under plagiarism. It falls under plagiarism, and you can be, action in terms of disciplinary can be taken against you. So my advice is, when you're coming into class, just take your attendance. And if you have a friend that is asking you of the code, you just have to tell them one word, which is called Dr. Hema. Just say Dr. Hema, right? And they would not ask you of the code, trust me, okay? So I would not want to catch any of y'all helping your friend fake the attendance code. Reason being is, you're not helping them with the academic integrity as well as knowledge for this module. And eventually I'll be able to know who are the kids who are not in class when I start to see you in your tutorial session. Sweetheart, the boy in the green sweater, come down. Come. So if this is, there's a lot of empty seats here. We're just not taking the 4 rows. So if this is the class that I'm going to have for the next consecutive lectures, I would really appreciate, I'm being very humble, I would really appreciate if you don't take the 4 rows, because I'd like to have a very good relationship with my students. And I find that, you know, when it's a smaller class, I can build a bond with y'all, and I'll be able to identify some of the weaknesses that each and every one of y'all have. Not in lecture perhaps, but in tutorial sessions, okay? So I think the take back today is, do not share your attendance code. I don't think you want to know what's the penalty on my side. For me, if you share attendance code, outright your assignment 0. That's it, no questions asked. So today in this class, I'll tell you if attendance codes are shared, just one mistake you do, and trust me, for some reason, I'll find out. I would ask the person who gave you the attendance code as well as the person who has asked for the attendance code. Both of them will get the assignment 0. And your assignment is quite a weight here. So just take care of yourself, lah, huh? Right? Okay, so this is your code for yourself. Right? Okay? Right, so there's 2 things that I'm going to do today, given the time that we have. So I realized that the buffer that we have is about 15 minutes for us to come in, settle down, and get the attendance code. I would give myself another 20 minutes, 25 minutes to start week 1 lecture. And I would do the assignment briefing today. So I'm seeing one group of tutorial students at 1 o'clock later today. So if you are in their tutorial group, and I see, I think 2 on Wednesday, and I see another 1 on Friday, I have 4 tutorial sessions. Immediately after the lecture session today, your first tutorial will be your first practical. And I've already posted up the practical 1 questions. So what you need to do is, when you get into the tutorial session, if you have yourselves in your groups, and I did do this in the briefing of the lecture last week, you should get yourself into a group of 5, and you should try to work on tutorial questions with that group, right? And maintain that group for the assignment. So again, before I see the first group at 1 o'clock, have your group of 5, because it's great to attempt your tutorial questions in groups. That encourages a lot of soft skills, collaboration, interpersonal, teamwork, and stuff like that. That's what I'm advocating, right? I know you can do a lot of stuff on your own, but I think you can do greater stuff when you have a few minds that blog out with each other. Okay, right? So without further ado, let's get into the first lecture. What I'm going to spend on today is, I'm going to get you to understand what is software engineering, right? So don't be so alarmed with the number of lecture slides. All right, we will run through it as we go, and whatever that I don't cover in class are things that you should read up on your own. But of course, yeah, I know you're all very exam oriented also, but of course, if you were to ask me, okay, miss, from this week 1 lecture, what would be the take back? I would do that at the end of the day, right? Before the lecture ends. And I would also tie up with you what potential exam questions can. Of course, the exam paper is not created yet. We usually would create it probably at the 6th week, right? So as we go into the semester further down, I would tell you which particular questions I'm wanting to explore with you, okay, for each lecture. Okay, so let's try to understand what we're going to cover today. It's about 90 slides, but I'm going to try to sum up everything, right? And we're going to firstly try to understand what is software engineering. You need to understand the differentiating fact between software engineering and programming, right? And those of y'all who are in the software engineering specialization, you would know what you would need to take up with you in terms of your skills after understanding what is software engineering. And then when we look into the basic definitions of software engineering, you should be able to understand what's needed of you as a potential software engineer. So we have got the aspect of ethics, we have got the aspect of individuals, and we have the aspect of professionals that we are breeding among you, right, to go into the industry to become potential software engineers, right? So we're going to cover a little bit on ethics and what's needed of you in terms of conduct. And then, if we have time, we look a little bit into the types of application. But I think at the whole sum up of today's lecture, we're going to try to understand the processes that's involved in software engineering. And then that enables you to understand why we are taking on this module, and essentially every single requirement that fits itself under the domain of software engineering, okay? Now, so if you look at keywords, right, which is highlighted in red, when we talk about software engineering, I'm going to use very important keywords. They might not be the slides, and I don't read from slides. I just talk to you about it. All right, slides are there as your points, okay? So when we talk about software engineering, right, it is a domain, okay? And software engineering takes through a series of processes. And who is the person who takes on those activity in terms of roles and responsibility? You have software engineers, right? So do software engineers, part of their job description, code, program? Yeah, that's part of their work task that positions itself as an activity inside software engineering process. So what is software engineering? I'm going to use a very important keyword. The end product of a software engineered outcome, right, is a workable product, which we term as today, technological jargon, applications. So you can have it either web-based, mobile-based, interactive, or whatever, right? At the end of the day, the software engineering process will produce to you an application. Now, that application will be tailored to specific stakeholders. And that stakeholders, you will have direct user and indirect user. So the direct users are the people who will be using the application for their day-to-day operation. The direct user, every day they come to work, they switch on the application. Every day they come to work, they switch on the application because they have to attend to a customer. Not immediately, but the role they play, right, serves a very important outcome to the client or the customer. That's direct user. But what about indirect users? Indirect users are people who don't use the applications directly, but they depend on the information it produces. So they would be higher level decision makers or managers, right? And then they roll out into looking into performance of systems, right? So software engineer, the keyword I haven't told you yet, the outcome I told you is an application. For who? For stakeholders, direct or indirect users. But what's the keyword when we talk about software engineering? It's one word called systematic. Step by step. So software engineering actually encompasses a systematic flow to deliver your application. So in order for me to deliver the application, I have to take through systematic, step by step. So step by step means what? A methodology. So methodology is a method, a process flow. So the general principle of software engineering, right, it takes through what we call an incremental, or what we term as a flow of a waterfall, a step by step. One outcome of a process will be the input to another process or the next process. So when we look at software engineering, right, we are taking through a systematic process. So it starts from the very first stage of studying a potential problem, studying a potential opportunity, studying a potential directive. Directive means somebody tells you they want this. Opportunity is you see that a problem, right, or a gap is brewing. You see that it might not be a problem, but it can be an opportunity. A problem is blatantly staring in front of you that you have to improve. A gap is an improvement. That improvement, you look at an opportunity to make it better. So it starts from that study, problem, opportunity, directive, and then you go into, that's what we call preliminary investigation. Then you go into analysis, where you study feasibility, you conduct your fact-finding from the direct or indirect user, you design the system, you move on to development, you test the system, right? You deploy the system, you maintain the system, you support. And then you go back, that same system, you go back. Got problem? Got opportunity? Is that a directive? You go through that process again. So yes, applications have lifetime. But when it comes to a peak of the lifetime, you're going back to step one. Is there a problem with that application we built 3 years ago? Is there an opportunity to make it better? So software engineering is that systematic process flow. It consists of activities, it consists of a large number of stakeholders that play a part, whether or not the analyst, the developer, the user, the sponsor, right? Or your external suppliers or your vendors, whoever, they come together, they ensure your scopes are outlined, they work by that stipulated timeline. They have got a limitation in terms of cost or budget, but at the end of the day, the outcome of a well-engineered product delivers to you an application. And that whole scenario, if you look from top, it's project management. So a project that you manage in our situation, in our domain here today, you're managing a software development, taking on software engineering principles. At the end of the day, your application. That's what software engineering is. And you, bachelors of software engineering, your whole 3-year course is progressively understanding every stage. That's why you have modules that teach you programming language. You have modules that teach you testing, right? all the integrity testing, unit testing, module testing, whatever. You have modules that teach you communication. You have modules that teach you design. This module, design. So whatever you design logically flows out to your developers. At the end of the day, your user, here's the application that you asked for. That is what software engineering is. I probably summed up 30 slides already. Right? So, there you have the process, and then you come to a situation where you can read all of this, right? There are situations where softwares and engineered processes can fail. And failure is the cause of error. Who creates the error? Who creates error? Who creates the error? If the engineers are the ones who are creating the application and delivering it, who creates the error? Anyone can just shout out. It's okay, guys. Don't have to be a one-way communication. You can just tell me. It's all right if it's wrong. It's all right. User? People. Although, you know, today in many situations, if your application doesn't load, the first thing you do is, what kind of application is this? What kind of computer? Your computer gives you problem, you scold the computer. But at the end of the day, you look behind, you look left, you look right, you look top, you look bottom, you look in the mirror, you blame yourself. Today, failure, I'll tell you very honestly, failure, source, people can blame the application, right? Oh, it's not churning out. Oh, the design's not what we want, right? Oh, the verification is not done very well. Oh, it's garbage in, garbage out. But at the end of the day, who's to be blamed? People. People. The designer will blame the analyst. The developer will blame the designer. You gave me the design. I developed it exactly as how you obtain the requirements from the user. The analyst turns around. No, I took exactly what the user says. The user looks at the analyst. No, I didn't say that. Of course, in front of the user, you can't say, you're contradicting your point. No, you cannot. Oh, yeah, you know, behind to the developer, they don't even know what they're doing. That is the scene in any software house. In front of the customer moment of value. Yeah, no issues. We can change it. No problem. Behind, we're screwed. We're screwed. So failure, which is not any, is a game plan that every software consulting house, small or large, of course reputation for large, for smaller mushroom software houses, it's also your reputation, right? But in a very minimal way, failure can be caused by your process. Your process, point number one, hiring the wrong person for the job. So today when people interview, right, an analyst or a product owner, they are not looking whether you are hard skilled. They are looking whether you can communicate well. Because you have to be the front face with the client. Can you interpret? Are you reliable enough to study your client and engage with him? Are you able to create a good bond with your client? That is what people are looking for today. Because at the end of the day, let me tell you, failure, the reason is wrong people for the job. Because at the end of the day, it's called accountability. You're accountable for your role. So if you talk about accountability, right, you can look into something called, hang on, I'm just forwarding it up, okay? Just all this you can read. I just summed up everything. You know what? I just summed up all of this. I summed it up. You can read, right? What I want to talk to you about is this. When I talk about people, ethics. What entails ethics? A, ACM, the Association of Computing Machinery. Not now, but later when you do a Google during your tutorial, you will see that every computing industry or graduate, you should carry an oath, which is what we call ACM Principle and Code of Ethics. Before you enrolled, it was a joke that we did in the academic, before any student enrolls for computing, the first day everybody should take an oath. The oath will be ethics, which is 1, responsibility, confidentiality, competence. Engineers should normally respect the confidentiality of their employees or clients, irrespective if it's being a pain in the ass, it's okay. Confidentiality, right? If he doesn't know anything that he's talking about, when I go to my team, which was the user? Confidentiality, you cannot share. You have to protect. And the thing is, you are studying this in education. I'm inflicting good values in you, but I'm inflicting theory values in you. How do you apply your theory? When you go into your assignment groups as a project leader, right? If one of your members says, who among the 3 of them who didn't want to do their work? As a project team leader, you keep it confidential first because you want to try to manage the team. Not poke fire of this fella to that fella to this fella, and at the end of the day, you know, you're sitting comfortably because you've just spread all the bad rumors about everybody else except for yourself. Is that a good ethical value to take on to yourself? No. What I'm trying to tell you is inculcate the value here itself, so that when the doors of employment or internship opens, you practice this long, you preach it. When you go out there in employment, it will just be what you do all the time. It's not something that you have to change about yourself. Do you understand? Yes. So, inflict the values here itself. Study people. You get into a group discussion. I challenge you. I challenge you not to take your friends that you've worked with for your assignment. I challenge you to come into the tutorial class later, get up, walk to a person you don't know. Hi, my name's Anna. How about you? Daniel. Would you like to set a group up with me? No, what you all do is, you all look left, not nice, doesn't look good. Okay, looks a bit scary. Okay, no eye contact. Never mind, I'll just wait lah. Somebody will just tap me on my shoulder, right? But some will be bold. Some, you enroll with 5 of you all, you made a pack. All assignments, we are together. You made a pack ready. That's not the way it goes. And when you come into tutorial session later, I'm the devil. With 25 years of teaching experience, in tailors being near to 10 years, I will tell you I'm the devil. I will go into groups. How many? 5. Happy? Yeah. You come out. I'll do that later. Huh? I say, you join this one. You join that one. So you just, during your tutorial, happily ever after, just sit with your besties that you have formed, your perfect so-called group. Right? And then I will rock the boat. I have the autonomy and authority to do that because I want you to challenge new people. I want you, today, my final year students in internship now, right, they don't have problem working with any shape and size and attitude because I've thrown them into the deep waters. They've even come to me and told me, Miss, it's my final year, how can you do this to me? How can you put him in my group? I said, too bad. I said, in your lecturer survey form, just put me as one, the worst lecturer ever. Put, it's okay. It's all right. My brownie points are earned. And they'll just huff and puff, and today they are in the industry. Miss, guess what? We have another Alex in our team. So alike, miss, and I know how to handle this guy. That is the experience that you get. Trust me. So when we talk about ethics, everything, IP is also ethics, intellectual property. Whatever is the IP rights, if you join an organization, you must understand. If you're part of an organization that does a lot of research or does churnings of softwares, programs, you must understand that you are contributing to the organization. So when you sign your employment contract, it will be stated. All the softwares that you build within this organization lies in the property rights of the organization. No matter how much of intellectual, smartness, knowledge, skill that you huff and puff, you have tirelessly worked for the organization, at the end of the day, the IP will stay with the organization. You respect that, you sign your employment contract. You don't respect that, you go start your own company. Fun fact, all your FYP projects in the university, any university, is held in the rights of the university. So whatever project, let's say you created an awesome project, commerciable, you can commercialize it, and then you go and commercialize it. You can get a knock on a hypothetical situation. You can get a knock on the door saying, this project, your FIP license stays with Taylor, so 60-40. Sign lah. Whatever you create in this university, it's not, again, fun fact, it's not only Taylor's, all the university. As long as you've enrolled yourself as a student of this university, whatever projects you create, maybe the small ones or bigger ones, potentially marketable, potentially deployed, potentially commercialized, the rights remain with the university. And you have to respect that. So you have to be smart. I won't tell you how. Okay? Now, so this is the ACM Code of Ethics. Why are we learning this? Light bulb moment. Software engineering entails itself through systematic flow. You do your investigation, you do your analysis, you design, you develop. There has to be somebody who's doing that, the person, i.e. software engineers. Software engineers, put an oath up. I hereby confirm that if I'm an engineer and I work for a particular organization, I will ensure that I abide by the code of professional conduct. Oath you pick up. The oath starts with just what we call ethics. I know ethics is a personal interpretation. Ethics is a personal interpretation. For example, the class ends and everybody walks out. The last person walks out. I even walked out. Last person walks out. Just before you open the door, you see 100, let's not use Malaysian currency, $100 US. Yeah, just at the door. You're going to open the door and you say, oh, 100 US. Nobody is in this class. I'm questioning your ethics. Huh? Nobody is in this class. And I'm not going to ask you what each one of you all are going to do. Huh? I don't want to know. I really don't want to know. So you see 100 ringgit. As you're just exiting the classroom, you see 100 ringgit. Now, what will you do? I'm not asking you. I'm not asking you to tell me verbally out. You think quietly, zip it, because nobody wants to know if you're going to take it. Then they'll judge you. Right? How many of y'all will do, I think, majority of what everybody? If I said Malaysian ringgit, you'll probably just walk past. That's why I put a raise the dollar up, it's $100. How many of y'all will walk and then look at it like, How many of y'all will do that? How many of y'all, rewind, Oh, so somebody dropped it, you know, how do I get hold of Dr. Hema? Where do I walk outside? Hey, where do I find, you know, lost and found? Can I, you know, yeah, go here, go there, you know, and then send me a Teams chat or whatever, you know, put in an announcement or send me an email, miss, I found 100, I'm definitely sure it's from our class. I'd like to give it to you, you know. How many of y'all will do that? You don't have to tell me, keep it yourself, right? How many of y'all will pretend it was there, but, you know, I mean, just walk away because I don't want responsibility, right? But think about it for a little while. How many of y'all, as you walk past, the first notion, not the guilty prick, the first notion, take it, oh crap, somebody lost it. Somebody really lost, I mean, it's a US dollar, somebody really had it as a pocket money. I don't want to think whether it's dirty money, right? But it's somebody's pocket money. How many of y'all immediately will be deontological? That means you're rule-based. In psychology, we call it deontologist. Rule-based. Immediately, not even left, not even right. Somebody lost it. If you practice as such, I'll tell you, your values are from your ground. It's from how your parents have really brought, and you've really moved around your social circle that is very, very rule-based. That means when you're driving in a jammed up place, no matter what, you will never take the emergency lane. You will be in your lane. How many of y'all will be a utilitarian? You see it, then you ponder. Okay, now, if I take, what will be my risk? If I don't take, okay, let's weigh. Which one is higher? Which one is less risk? You are a utilitarian. You weigh the greater benefits. But at the end of the day, it's a benefit yourself. How many of y'all will be a relativist? 100. Anybody who sees it will take it. I also will join the bandwagon. I'll take it. Because many people will take it. In Malaysia, take it. So how many of y'all will be like that? In any one of the given psychological, ethical principles. You don't have to give me the answer. Similarly, as a software engineer, you have to ensure all of this, 1 to 8. For example, I take one of it. You are going to walk into a client. If let's say you are like companies like Infosys, one of the large software houses, you're going to walk into a client company and you're going to start to look at people who look at you as if you're bringing, you know, a change of a breather, right? To either improve their current or to create something to ease their task. So when you walk into a client, you are coming as, you know, like a solution provider. The first thing, I just take one of it. Client and employer. Software engineers shall act in a manner that is in the best interest of their client and employer, consistent with public interest. 1, I will know he's my client. Respect. Be humble. Right? It does not mean you know more and they are stupid. So if you are humble and you treat them well, they will reciprocate and they will want to work with you because change is imminent. People don't like change. They never like to rock the boat with something that they are so comfortable with. So if you can change that perception in them because you have respect for them and you show it in day one, when you're introduced as the team, you're already carrying the oath. It's public interest because if I screw up their solution, the reputation of my client company goes out. I still don't care? No, hang on. People will ask, hey, who's the people who created their solution? Who did they engage for this software solution? Infosys. Now, indirectly, it will affect you. Organization, right? Still organization name, right? But internally, who was part of the project? Oh, Chen was leading the team. Now, it will somehow come to people. Correct? So the most important principle as a software engineer is you have to take the oath of the principles of becoming a person that's inclined to follow good ethical practices, and under the engineering principles, under ACM, the Association of Computing Machinery, you abide by these 8 principles. So look at the last one, self. Software engineers shall participate in lifelong learning regarding the practice and shall promote an ethical approach to practice. So, lifelong learning, you have a team to manage, you want to upskill yourself so that not only for yourself, because you can take whatever that skill or knowledge you have, you come back and you contribute to your team. Indirectly, you contribute to your organization. And if you can do that, then you are very happy waking up every day. And if they recognize you for it, you will love what you do. You will be passionate about your career. Else, you'll still be finding yourself. Yeah? Okay. So, some fundamentals of software engineering, right, we need to incorporate. So, today, let me tell you, in traditional, we have quality standards like ISO. They are a regulatory body. ISO, I'm just giving you one example. ISO is a regulatory body that comes up with standards that govern certifications. We have a lot. We have Six Sigma, we have ISO. Six Sigma is more for processes. ISO is more for product, right? So in software engineering, a lot of organizations will want to get the certification of ISO. That means it's audited, and your product, if you release, reputable because you have conformed to the standards. One time, few years ago, quality was just an overseeing standard. Oh, okay, you're following a standard, all right, great. But today, quality is a culture. It's a culture meaning in organizations today, people are creating a very, very classical framework to ensure that quality is denoted from the very start that you sign your employment. When you do onboarding, part of the briefing that will be done for you is we have a quality department, and we would like you to understand what and how we do conformance of checks for our software. Because today, in many software houses, quality has become a department, and quality is a team of people who many engineers, analysts, product owners are afraid of, because if you create a project and you want to release it tomorrow, and quality oversees that the project does not conform to the user requirements, quality has got the liberty of raising the white flag. No release. Cannot release. Not conforming to requirements. You work for the organization, you're a quality department team, you are raising the white flag. Really? No, yeah. Because I'm raising it here now. No, but the testers found no bugs. No, it's not conforming. No bugs equals to an application that works. But does that application that conforms to what the user wants? It doesn't conform. Whether in terms of efficiency, security, reliability, general quality, I'm raising the flag. Stop, no release. So that's why a lot of software houses, they get stagnant with deadline of release. That's why they go into revisions, versions, variants. So software quality can stop, because for software quality, I'm not going to shortchange the reputation of your organization and for the company to incur post-release costs. Because post-release costs is all about callback and reputation. It's better I stop the release Okay, you'll get slapped left, right, and center because there's a delay. But wasn't that delay an anticipated risk because of the technology and the resources you invested in? So that's why in any project, risk, pay very close attention, your tutorial work. Risk is a very important study that any individual has to take before they sign the agreement that, okay, I'm hiring you as my consultant to build my solution. In the business case or in the charter, you will have to outline what's the risk. So if you've already outlined the risk here, and when software quality on this side before release says, no release, not conforming, we did our audit already, you're not conforming. We raised an alert halfway, but nothing was looked into. We are not releasing. No go. Change your deadline, contact your client, right? Wasn't there a potential risk? Something you risk, whether hiring somebody not competent or hiring somebody very competent, but suddenly at the end not available or not able to troubleshoot, or looking into features of system that cannot get done. So, stop. Software quality will put a barrier. They said stop. It's a now, not one person saying stop. And you know, like, stop. Now, stop, because there's a department. I back up with my department, what? It's a culture already. So they are very proud. Why stop? All this checklist, from the very start, there has been non-conformance. Nobody has been looking into it. For y'all, it's just release. For us, it's the quality of what you're releasing. Not about testing and finding bug. It's garbage in, garbage out. You got a garbage out that's working, but is the garbage out working what the user wants? Not only what the user wants, what he needs. So at the end of the day, today, quality are the people that software developers and the whole engineering team are afraid of, because they can wreck your plan. But if you work with them and get them to work with you on checklist, then you're safe. So that's why today it's a culture that they define in the very end from top management. When I hire, guess what type of people you need to work in quality department? Rule-based. You're my friend, you're my developer, you know, you talk to me every day, you tell me all your challenges, I won't feel pity, right? And I won't let it go because I'm rule-based. You can be my friend, but you've messed up. And we've got to stop the release. Very rule-based. That means the people that are interviewed for quality, and if you want to find a job as a quality analyst, you have to have an attitude and a character, and your values and your character has to be very rule-based. Nothing doing. Stop the release. I will explain why. I have my facts, right? I will tell you why it does not conform. Because it's been audited, doesn't conform. So stop. Stop the release. In education, don't offer that subject. In the next semester, clean it up. Only the following semester can offer. Because when audited, either it's not meeting the requirements, either the materials are not necessarily in par with the depth of the outcome of the module. Stop. So I'm saving you actually. Before it goes out, imagine when it rolls out, and imagine the cost you have to incur to call back. That's not just cost of rework, but it's cost of reputation. But of course, let's not talk about all the big giants, right? If Google makes a mistake, and they call back, it's just Google, you know, just 1% loss maybe, right? So sometimes it's unfair for large conglomerate organization to use the advantage of their reputation, right? And if it's a small glitch, it's okay. The amount of glitches Microsoft has, the amount of glitches SAP has, you know, but it's okay. It's all right. Our brand's already there. So that's why many organizations today want to work with mid-level, if at all, startup companies, because they are there to build their reputation. So when you build your reputation, you ensure that your processes and your product are churned out with quality. Yeah? Okay. What's my timeline? I have 15 minutes. I want to do the assignment requirement. Whoa. This is the problem when I lecture. Time runs. Okay. Let me just run through. I have 5 minutes, 6 minutes. Okay. I will run through the assignment very fast, very quickly. I'm pretty sure it's not going to make any sense to you. Pretty sure. Okay. I'd like you all to just start with the basics. Look at the handout date, which is this week. It's done during lecture. So your hand-in will be the Monday of week of 2nd. So week of 2nd, so rightfully today is the 30th. Your submission deadline will be the 2nd of November. It's 30%, and you have to ensure you have a group of 5. This is the cover sheet that you will use as the main cover for your assignment. Put your name of your group mates and yourself and your student ID. Now, what we are trying to achieve in this assignment is basically you're going to take through the whole process of software engineering, but the thing is you're not developing it. You're stopping in the phase of design, but you are just creating some conceptual logical screens. Today we have a lot of softwares available for you to just play with screen designs, right? So it stops at design. You're not developing the system. So we are actually we are deploying software engineering principles where we're taking it through a development process, right? It's called development process, but you are stopping at the design. So what you need to do is you need to first find out the requirements. You have to demonstrate by applying. So I will tell you very honestly that the core of this module lies in the modeling techniques. Next week onwards, perhaps not next week, perhaps the following week, or we could touch on it next week too. We will start into the UML modeling, the Unified Modeling Language diagrams. We'll start with use cases, right? So every week, we'll probably do 2-3 use cases, and your tutorials are going to be breadth and depth on modeling. I'm going to give you a lot of exercises to play with. I told you to have Draw.io in your laptop, but the labs are all configured with Draw.io, and you're going to start to understand modeling. So, for example, if I were to tell you, hey, movie ticketing system, okay, draw a use case diagram for it. Your use case will be different from his use case, from her use case, because your scope of your movie ticketing will be different. But then the essence of buying a ticket and paying for it is common. So we're going to play with creative minds, and we're going to have 1 or 2 groups presented during tutorial sessions. All right? So the depth of this assignment is for you to first thing you need to do, very important before the class starts holding me outside, is go and read up what SDG is all about. So if you look at SDG, Sustainable Development Goal, it's everywhere. In fact, I think last week, one of those pop-up stores, you know, at the Student Life Center, there was one, I'm not sure whether it's students but outsiders, but their whole booth was SDG. I was like, crap, my students have not started the assignment, you know. They had badges, they have knowledge, they had a video going. So in your case, we're running out of time. What you need to do from now until 1 o'clock, your tab on your phone, browse out what Sustainable Development Goal is, and this is worldwide. So there are about 17 Sustainable Development Goal main core, right, values and headlines. Among your group, you have to choose one that you are passionate about. Study a system that's existing that has got some problems through research papers, and then you identify some solutions to it. So when you build that solution, you have to take through the modeling, use case diagram, class diagram, sequence diagram, activity diagram, and then you present your work. 20 to 25 minutes per group, and that will be presented when you complete your assignment. I have changed this module from 2 assignments. Last semester they had 2 assignments, which was rather heavy. I've changed this to 1 depth assignment. So you only have 1 assignment, 1 test. And this assignment carries 30%? Yeah, 30%. And the test also carries 30%. So my advice to you is to change your attitude, put a different cap, start to be a very contributive member to the assignment, because I don't have any qualms to give a 0 for a member who's not working. It's very simple. So I want you to be a very productive team member in your assignment to justify that if that group gets, without the presentation marks individually, gets, let's say, out of 30, let's say 25, your contribution is well worth that 25 as a team. So hence, the most important thing is group leaders who are selected